Voltaic cells. A voltaic cell is a device in which the transfer of electrons takes place through an external pathway rather than directly between reactants. It is used to harness the energy of spontaneous redox reactions. Spontaneous redox reactions are the chemical reactions in which electrons are transferred from one atom to another without the need of outside energy. Voltaic cell utilizes the flow of electrons of the spontaneous redox reaction to create a current. The current is then used to do useful work. There are four main components of a voltaic cell. Electrodes, including cathode and anode. Two-half cell compartment for reduction and oxidation, a salt bridge, and a metal wire. The metal wire serves as the external pathway for electrons to go through, and it is usually copper because copper is the second most conductive metal. The voltmeter is an instrument used for measuring electrical potential difference between 2 points in an electric circuit. Since a voltaic cell is generated by spontaneous redox reaction, the value measured by the voltmeter is always positive. The positive side of the voltmeter is connected to the cathode, while the negative side of the voltmeter is connected to the anode. The two solid metals that are connected by the external circuit are called electrodes. Anode oxidation occurs at anode, while reduction occurs at cathode. It's easier to memorize it by thinking anode and oxidation both start with vowels, while cathode and reduction both start with consonants. The electrodes can be made of materials that participate in the reaction, or some conducting but not reactive materials, such as platinum, graphite, silver, or gold. Since the anode is less electronegative, which means it's willing to give its electrons away, and it has a higher potential energy, so electrons always flow from anode to cathode through an external circuit. The anode is also marked with negative sign, while cathode is marked with a positive sign. As the reaction goes on, more electrons flow from anode to cathode, making the cathode more negative and making the anode more positive. The buildup of the large negative charge in cathode compartment will repel the flow of electrons, causing the reaction to stop. A salt bridge is then used to complete the circuit of a voltaic cell. Salt bridge contains a strong electrolyte solution where ions do not react with other ions in the cell or electrode materials. Anions always migrate toward the anode, while cations always migrate toward the cathode to neutralize the charge of the cell compartments. So here's an example of spontaneous redox reaction between permanganate and iron 2 ion in acidic solution. To determine which ions and element go into which compartment, we first need to write the oxidation and reduction half reactions. In this case, iron 2 is oxidized into iron 3 ion, while permanganate is reduced into manganese 2 ion. Since iron 2 is oxidized, we put both iron 2 and iron 3 in the anode compartment. And since permanganate is being reduced, we put permanganate, hydrogen ion, and manganese ion in cathode compartment. Remember that this is based on the oxidation and reduction half reactions, not on reactants and products from original equation. So hydrogen ion is placed in the cathode compartment. Here is another example to show the molecular view of how the cell works. Again, we have to write the two half-cell reactions first. Zinc is being oxidized. Zinc is oxidized into zinc 2 ion, while copper 2 is reduced to copper. One way to know which half-cell reaction is oxidation or reduction is by locating the electrons. So oxidation is the loss of electrons. So electrons will always occur at the product side of the reactions. So we can interpret this reaction as zinc loses 2 electrons to form zinc 2 ion. The same reasoning for reduction. Reduction is the gain of electrons. So copper 2 ion gains 2 electrons, become copper. So the electrons in reduction half reaction will always on the reactant side. Since there are solids in the reaction, zinc can be used as anode and copper can be used as cathode. When the reaction occurs, the zinc atom loses 2 electrons and it dissolves into the solution to become zinc 2 ion. The 2 electrons will then travel toward the cathode. When it passes through the voltmeter, there will be a reading because the flow of electrons created a current. And you may wonder, why is it 1.10 volt? So in this example, we assume the reaction takes place under standard condition. So the standard condition for voltaic cell is the temperature of 298 kelvins, 1 atmosphere of pressure, and 1 molar of concentration for all solutions. So when the electrons flow toward the cathode compartment, it attracts the copper 2 ion, and they will form copper atom. So to complete the circuit, the strong electrolytes, in this case it's sodium nitrate. The salt bridge, the anions in the salt bridge will flow toward the anode. In this case, it is nitrate. And the sodium ion, which is a cation, will flow toward the cathode. So over time, there will be a decrease of anode of zinc strip, and there will be an increase in mass of the cathode, which is the copper strip. Also notice that the color of the solution in the cathode compartment becomes lighter when the reaction completes. This is because of the decrease in concentration of copper 2 ion. The solution turns from blue to light blue. Lastly, we're going to talk about the cell diagram. A cell diagram, or standard line notation, is a shorthand method of drawing a galvanic cell. It reads the galvanic cell from left to right, from anode to cathode. This cell diagram shows the standard state reaction of permanganate with iron 2. The single vertical lines represent phase changes between the solid electrodes and the solutions. The double vertical lines represent the salt bridge. The concentrations of the solutions are shown in parentheses. The order in which the chemicals are written within each cell is not important. So, to summarize what we just talked about, first, the voltaic cells are generated by spontaneous redox reactions. Second, reduction occurs at cathode while oxidation occurs at anode. Third, electrons always flow from anode to cathode. Fourth, salt bridge neutralizes the cell by having cation flows toward the cathode and anion flows toward the anode.